Okay, welcome everyone. In this video, we're going to learn about data types, variables, and identifiers. Okay, let's get started. Now, this is where we left off. This is a sample program in the code blocks. Okay, I'm going to simply explain what are all the different components. So in the next couple of videos, I'm going to explain everything clearly, different components of this one. Right now, I'm going to simply explain it. Now, let's just write our own simple code. Now, in order to run the program, you have to have minimum code, and now this minimum code is this. First is a preprocessor directive, hash. Now, this can be called hash or pound. I like to call it hash. You can call whatever you want. So, hash include. So now this is a preprocessor directive. What it does is it simply copies the content of this file and pastes here. These are the first directives that are executed. And now type int main, and now the int main, these are all in small letters, don't use caps, small. Open curly braces, and here return 0. Okay, now I'm just gonna drag this one to this right side. Now, so far the program is nothing but a preprocessor directive and a main function. Now, this is a function. Now, if I'm going to explain what function in the next video, maybe. So this is where our execution of our steps starts. Programming is nothing but set of steps, right? It's basically steps to achieve some objective. Now, this is the start point or the entry point for our program. This is where after the main, this is where our steps start to execute. So let me just write one command. Now I entered this command printf. This is a function. What it does is it basically take this string and print this to our console. And our execution starts here after the main first line, this fifth line. And after there is nothing there, only white spaces, and it will execute one after another until it encounters this return. When this encounters this return, our program was done. That's it. So now hit F9 or this build and run option. Now I incorporated some formatting. This is just introduce some new line and tab characters. And that's it. So it printed our string here. Don't worry about this printf function. I'm going to explain this later. This is one type of input-output function. Now let's just learn about variables and data types. What is a variable? Now if you study mathematics, you already know what variable is. It's basically a placeholder for some value. You write x something plus 2 plus 5 something. Basically it says take any number, add 2, add 5, like that. So in here in C, you can declare variables, but at the same time you have to declare what is the type of that variable also. Now the type of variable is required for mainly two purposes. First one, to determine the size of the variable, and second one, to know what are the operations allowed on that variable. Okay, because if you think about it, adding two integers makes sense, but if it is a character, adding two characters doesn't. The syntax to declare the variable is as follows. First of all, you write type whatever it is. There are different types. There is an integer, there is a float, there is a character, and then you give an identifier like x, y, whatever it is. So this is how you declare an integer variable x. Then you can assign any value to this. Now I'm going to assign it 2. Now this is how you assign the value for that variable. Now I assigned 2 to x. Basically x value now is 2. Now in this printf function, what I'm doing is I'm just printing the value of x. Now let's just run this code. Now this is x. Now x value is 2. Now you can assign any value to this thing like 55, 66, and run the code, and you will get that one. That is it, simply. And you can assign the value at the same time of its declaration as follows. You can say you can declare it and after assign some value. Now let's declare another integer variable y, and now you can do all the arithmetic operations x plus 6, and now you can print y. Okay, let me just print. Now if you see, my y value is 62. It evaluated this expression and assigned the result to y. Now you can perform any of the arithmetic operations like minus, this gives me 50, or the multiplication, this gives me 336. So there is a one key observation you have to make. So in mathematics, you write this becomes an equation. Basically it says my expression in the left will equal to the expression in the right, or my left side expression value is same as my right side expression value. But in C it's not quite true. What basically is that this is an assignment operator. What it basically does is it first evaluates my right expression, then takes that value and assigns this to y. Now why is this different? Now observe this one. So now my x, I already declared my x and its value is 56. But see, I can write it like this. Now observe this one. Now if you think this is an equation, this says x will equal to the x plus 1. But this is not an equation. This doesn't make any sense. Okay, this is not an equation. What in here it means is that take x and add 1 to that, and whatever the result, store it in x. So this equals in C is an assignment rather than equality. That is one key difference in C. And now first my value is 56 and I add 1 to that one and store my result in x. Now let's see what's my x value. Let me just print it. Now my x value is 57, and I can take away 1 also. Now if I subtract 1, my value is 55. This is the one thing that you have to remember. This is an assignment operator. Now consider this. Now I declared a variable x which is of type int and its value is 3. Okay, now I declared another variable y. Now y will equal to x divided by 1. Basically it returns x, but let's print y value. Now my y is 3. Okay, that is expected. Now if I divide it by 3, I should get 1 because x is 3. Now let's run this 1. Expected. Except if I divide it by 2, I should get 1.5, right? Let's see. No, I got 1. See, the reason is y is an integer type. 1.5 is a rational number but not an integer. But why we declared it as an integer? So there is another data type to store the rational numbers called float. Now this is the declaration of float. Will basically has type, identifier and the value of that. We can give the value later, but you can also give it like this. And let me just print float. Now this is my y 1.5. Now if you take x as 3 and let's declare another float y, and now my y will be equals to the x by 2. Now my y is 1.5. So float is another data type, and after this one there is another data type called char for character. Now this is a declaration for character, char, and any identifier. Okay, this is confusing. Let's just take x. Now char x, now x can be any character. Okay, now the way you assign a character is you have to put this in single quotation marks. This is how I assign the character k to x. Now I can print x. Now hit run. The value of x is k, and that's how you declare and assign the character to a variable. Now let's just consider this example. Now there is an integer x and a floating point y. Okay, now as I said previously, the execution starts at the top of here and continues towards downwards. Now first this is executed. Now int x, and now so x and y variables are created. Now next x equals to 5. Basically this assigns the value of 5 to x, and now observe this. Y, I'm actually dividing x by 2. Now this value is 2.5 and assigning this to y. Okay, now y is 2.5. Now I'm printing this y. Now observe this. Now the y value is 2, not 2.5. Wait, why? So the reason why this happens is x is an integer, and now if you do operation on this expression, what it returns is an integer. But as we already seen, integer can represent the rational numbers. So what we have to do, we have to explicitly say this x in here I'm using, think of it as a floating point number. Okay, that's what this is called casting, typecasting, and this is temporary typecasting. It does not change value of x, but it does change the type of x in this expression for temporarily. So it changes this x to float in this expression and then evaluates this expression. Now x now is a float. Basically it can be a rational number. Now if you divide it by 2, you will get, since x is 5, you will get 2.5, and the 2.5 is stored in y. 2.5. You got 2.5. Consider this example. You had a variable x which is an integer and a y which is float, and my x value is 5. Now if I add 2 to x which is 7 and divide it by 2, I'll get 3.5. But since x is an integer, I'm going to get only 3. But now observe this, if I add float to this one, what basically this does is it basically changes this type, this expression type to float automatically. Because when I add an integer and a float, the result is a float. So now I don't have to explicitly change my type x to float. I can easily calculate like this. So my y value is 3.5. This is another way you can calculate. Now, as I said previously, we need type for two things. First one, to know how much size the variable takes, and second one, and to know what are the permissible operations that we can do on that particular type. And now if you talk about the size, different data types have different sizes. The reason to this, if you think about it, we don't need that many bits or bytes to store a character. So we usually use only 1 byte to store a character. Okay, let me just show you the size of my integer, float and a character. Now here I had 3 variables. X is an int, y is a float, and char is a z, and I use a function size of which returns the size of these variables. And if you see here, my x was 4 bytes and my y was 4 bytes, but my z is only 1 byte. Because z is a character, we don't need that many bytes to store different characters. Okay, now if you think about this thing, this is going to be a problem for int, because if int is only 4 bytes, there is a maximum upper limit between which it can represent, but after that it cannot represent. So we had another feature in C to modify the size of the variable that we are creating. There are 3 types of modifiers. The modifiers are short, long and long. So short is guaranteed to be 2 bytes, long was guaranteed to be 4 bytes, and long is guaranteed to be 8 bytes. Let me just write an example. So the syntax of the size modification was like this. You had your size modifier, you put like short, long, whatever it was, then you usually declare what type it is, then identifier. Okay, now consider this example. We had xs variable which is a short int, and there is an xl which is a long int, and there is a long int xll. And if I run the program, and this is the size of xs which is a short, is only 2 bytes, and now xl is 4 bytes but xll is 8 bytes. And now this is the standard, this is as per the C standard, they are guaranteed to be that, but as per the standard the size of an integer is guaranteed to be 2 bytes. That's it. Usually in implementations it was 4 bytes. If you run the code in older processors, it may be 2 bytes. So always use size of function, which I'm going to explain maybe in later videos, if the code depends upon the size of a variable. And similarly for float also there are size modifiers. The size modifiers are, now the float size modifiers are this. There is a float, let me run the program. Now the float is 4 bytes and the double is 8 bytes and the long double is 12 bytes. Basically the more size, the more bigger the variable, the more precise the floating point is. Okay, I'm going to show the table that contains different data types maybe right now. Now this table shows different identifiers, and this table shows what are the minimum sizes for different data types. Okay, now let's talk about the identifiers. Now the identifier is nothing but variable names you use. You can use any name, but there are some restrictions. The identifier should always start with a character or an underscore. But after that you can have any character or a number or an underscore in the identifier. Now the identifier should be a continuous string without any spaces. And the capital and the small are treated as different. Now see here, the variable name is I then, in here is also I then, but the I is capital. So this and this variable is treated as different. And it should not start with any numbers. This is not a valid identifier name. And after the character it can have any number or an underscore in it. Now the C will store up to 32 characters from the start of your identifier, so don't use more characters than that. Nobody uses that, but still don't use more characters. And that's basically it for this video, and thanks for watching.